En la biblioteca encontramos una amplia selección de vídeos que, además de complementar los contenidos de las diferentes unidades del libro, motivan y consiguen despertar el interés de los estudiantes. Estos vídeos, por lo general de corta duración, son de carácter divulgativo.
It is tough to make a guess just by looking, as the shortening of the perspective makes measuring even more difficult. Yet in our measurements, it is perspective we will rely on for help. The two things we'll need are a set square with 30, 60, 90-degree angles and some mathematics. Let's measure the height of this cathedral. The large square in front of the edifice is just the right size to make these measurements. Stand facing the cathedral and make a mental note of your eye line at the side of the building. This line will be the horizon line. Put the set square in front of your eyes so that the longer leg is horizontal, meaning it is on the line that connects our eyes with the horizon line. Holding the set square, look in the direction of the line of the hypotenuse. You can do so by positioning yourself by the fixed position of the set square so that the two endpoints of the hypotenuse overlap. Let's see where the hypotenuse points. If it points right at the top of the tower, we are done. If not, go backwards until they do overlap. Then, pace off the horizontal distance, with 1 meter steps if possible, to the cathedral. This length will correspond to the longer leg of our set square. The ratio of the two corresponding legs of the triangle is equal to the ratio of the cathedral's height and the distance that has been paced off. You can now calculate the height of the cathedral from this pair of ratios. Leg A'C' is the height of the church. Leg AC is the shorter leg of the set square. Leg A'B is the length of the distance that has been paced off. And leg AB is the longer leg of the set square. It is clear in this picture that due to the similarity between the two triangles, the ratio of A'C' to AC is equal to the ratio of A'B to AB. Of all these, only leg A'C' is unknown. Enter all the known values into the equation and express A'C'. So the length of leg A'C', that is, the height of the cathedral is, according to our calculations, 82 meters. If you check, the encyclopedia says 81 meters for this cathedral. The height can be calculated with an angle function as well. Leg A'C' is the height of the cathedral. Leg A'B is the length of the distance that we have paced off. The building is perpendicular to the horizontal line segment that we have measured. The angle at the other end of the line segment is 30 degrees, which is a direct result of our measurements. According to the tangent angle function defined in a right triangle, the leg opposite the angle is divided by the leg adjacent to the angle. After some mathematical repositioning, we arrive at the height we were looking for, which is approximately 82 meters. This method is excellent for defining the height of separate landmarks with a vast open space in one direction.